Hiya. So yeah, first up, thanks for our sponsors, as you can see on the screen there, and thanks for John and his team for organising another great conference. So today I'm going to talk to you about application security and cheese. So yeah, you're probably wondering what application security has to do with cheese. Firstly, an apology, there's meant to be some cheese boards going around the room, but I spent all of the money on fancy graphics for the slides, so apologies for that. So what is the presentation? So really it's around what we can learn by applying the Swiss cheese model to application security, and I'm going to use the model to have a look at some of the human factors in application security. So what we're going to cover what the Swiss cheese model is and its main features, some examples of where it's been applied, how we can relate it to application security, and what good looks like from our cheese board of defenses in application security, and how things can still go wrong and how we can potentially prevent those. So first off, as I said, we're going to explain a bit around a high level of the model and what it's been used for. So in 1990, Professor James Reason came up with a Swiss cheese model of accident causation to explain how accidents can occur in complex systems such as those in healthcare environments. As with many complex systems, medical systems require some human input, and with that human input brings the inevitable human errors as well. And Reason said that errors should be seen as a failure of the system rather than the result of one person's actions in that system. So those system errors, as you can see on screen, can be prevented by a series of defenses, barriers, and safeguards. Those are the slices of cheese on the diagram. Defenses are based on the assumption that we cannot change the human condition, but we can change the conditions under which humans work. So in an ideal world, each one of those defenses would be completely impenetrable, but in the real world they aren't, so Reason likened them to slices of Swiss cheese. It has holes in it. If an error occurs and gets through one slice of cheese, then hope is that the next slice of cheese will catch that and the losses will be prevented. However, sometimes those holes can align and the losses in the system can cause losses rather than system, or in case of the healthcare system, harm to the patient. So as well as being used in medicine, it's been used to explain and investigate aviation accidents, such as the Challenger space shuttle disaster, and industrial accidents such as the Bhopal chemical disaster in India and the Chernobyl nuclear disaster. And the post-analysis of these virtually always reveals that the root cause was a failure of multiple levels and the layers of defense, not a single layer. So looking at a couple of the key features of the model, so what can cause the holes in the cheese? So we've got active failures and latent conditions. So active failures are the unsafe acts committed by people who are in direct contact with the system. So these take those four forms there, so slips, lapses, mistakes, and violations. So slips are where the correct plan is made, but incorrectly executed. So you're meant to drop the kids off at school, but you went into autopilot and took the route to work instead. Lapses, so this is where you forget to do a step of the plan. So your home insurance perhaps becomes invalid because you failed to pay the bill. Mistakes, so this is where you've got misinterpretations of the relevant rules. So you interpreted your flight check-in time perhaps as 9 a.m. but arrived late. Violations, so this is where a person knows the rules but doesn't follow them, not intentionally to cause harm, but often to save time or complete a priority task. So at Chernobyl, an example of this was that the operators incorrectly violated plant procedures, switched off successive safety systems, and that caused the initial trigger for the accident. So the other part of the model are latent conditions, and these have two kinds of adverse effects. These arise from decisions made by designers, builders, procedure writers, and top-level management, and have two effects. So it can be that they create error conditions in the local workplace. So this is things like the time pressures or understaffing, poor supervision, poor communications. Or it can be that they create long-standing holes in the system. So this is deficiencies in design or construction, ineffective equipment, unworkable procedures, untrustworthy alarms or indicators. And these lie dormant in the system until they combine with one of those active failures to create an opportunity for an error to occur. So unlike the active failures, which can be really hard to foresee, the dormancy of these latent conditions gives us quite a good opportunity to spot them and try and remove them. So recent example of how the model's been used is to explain the defenses against COVID. So as you can see, there's multiple layers of defense. So things like mask wearing, hand washing, testing, vaccines, all the good stuff that we know and love. And so have a look at a couple of examples of potential active failures in here. So people forgetting their masks or leaving them at home. That would be an example of a lapse that makes the defense ineffective. Time pressures as well. So if it says if limited, if crowded, rather limit the time. So perhaps you're going to be late for work and you just had to get on that bus when you knew it was quite crowded, and that was going to increase your risk. Some possible examples of latent conditions that could affect those defences as well. So people not knowing how to wash their hands correctly. So perhaps talks to some inadequate guidance. I know in the UK we had this brilliant thing where you're meant to sing a song that lasted 30 seconds, like Happy Birthday, and wash your hands to that to make sure you were doing it for the correct amount of time. Or perhaps some poor communication about the different rules under the different COVID levels. Obviously, New Zealand did a really good job in terms of the messaging around that side of things. So how can we apply it to application security? Well, my first question was, can we apply it to application security? Well, it's been applied to other areas of cybersecurity, so I thought it probably could, and I hope so, otherwise it would be a really short presentation. With the Swiss cheese model, Reason was trying to move people's thinking from treating mistakes as individual errors by bad people to a systems approach that accepts humans are fallible and mistakes to be expected. Well, in application development, it's a human designing the application, it's a human developer coding it, it's someone configuring the infrastructure to run it, and each one of these are prone to the person potentially making mistakes. And in cybersecurity, we have the long-standing concept of defense in depth, which again, the Swiss cheese model talks to nicely. So how can we apply the Swiss cheese model to application security, and what would we be looking to achieve with those different cheese slices? Well, for me, it's around reducing the risk of vulnerabilities or security flaws being introduced into the applicational system under development. So why would we want to reduce these risks? Well, I'm kind of preaching to the converted a bit, but reducing these risks reduces the chances of those vulnerabilities making their way to the production application for a potential attacker to exploit those, leading to cybersecurity incidents that compromise your assets and cause losses. So what are the risks in an application security context that we want to reduce, and what human factors play a part in those? So the first one is around creating a security flaw in the design or the architecture of the system. So this would be considered one of those latent conditions, a flaw in the design opening up the hole in that slice of cheese. Accidentally introducing a security or issue or vulnerability into the code. So this is where you're developing your own code in-house. This could be down to active failures, perhaps a lapse by the developer forgetting to use an input sanitization function, or forgetting to remove a hard-coded API key in the code, and that's slipping through into your repos. Or perhaps a violation. So the developer knew they needed to introduce a bit more code into the function to secure it, but they were under time pressures, so they didn't, which possibly also talks to some of the latent conditions about those time pressures as well. So the third one on there is around bringing in supply chain-based vulnerabilities. So this is in the dependencies that the application uses. So this could be caused by slips by the developer, forgetting to upgrade to the latest version of the dependency, leading to an older version being used which has vulnerabilities in it. Or it could be around selecting an open source project that does what you need functionality-wise, but hasn't had updates in a while, hasn't been well maintained, doesn't get frequent security fixes in a timely manner. And that really talks to sort of latent conditions. I think that's probably the equivalent of choosing poor equipment in the system. So the next one is inadvertently putting a security issue or vulnerability into the infrastructure setup and configuration. So this could be traditional on-prem or could be infrastructure as code. In the infrastructure as code world, you could have a lapse and accidentally set up an S3 bucket as public when you meant to set it to private. Or it could be violations, so not following the correct procedure and removing all the unused ports and services on a server before you put production applications onto it. And the last one in there is somebody maliciously introducing a security issue. So this is the insider or potentially an attacker that's got quite deep penetration into your networks and applications. So for me, this probably fits into a violation, but with an intent to cause harm. And part of this may also talk to the latent conditions. Why did that person kind of turn rogue and decide to, introduce deliberately security issues and vulnerabilities into the code? So next up, we're just going to have a look at kind of the overall sort of application development environment. So we're going to look at the top row there, which is in orange. So this is your typical kind of waterfall method of the software development lifecycle. So you've got your requirements, design, and architecture phase. You've got a development phase. You've got testing, deployment, and maintenance. So it tends to be in waterfall over quite long periods and less frequent deliveries. And then in the sort of the more modern world, we've got CI/CD, where we've got the plan, the code, the build, the test. We've got that repeat of if your tests fail, go back to coding, building it again, and retesting it. And then the deployment side of that. So we've got releasing and deploying it and operating and monitoring it and that constant churn of that. And that's aimed at, ideally getting a feature into the system, coded, tested, built, and released perhaps in a day or a lot shorter timescales anyway than the waterfall method. So each one of these different distinct phases gives us some really good opportunities to layer in those slices of cheese. So this is the first use of those really expensive graphics that I mentioned. Quite expensive, but still cheaper than buying an actual block of cheese in New Zealand. So what does a version of good look like when it comes to the defenses in the system? So this is some of the typical security activities. I'm going to talk this through by two different scenarios, which are the red lines going through the slices of cheese, and I'll relate those back to the risks that we were talking about. So the top line in here is where a developer's introduced a vulnerability into the code. So I'm just going to take an example. He's used a JavaScript eval function, which is a nasty thing to use, and they've got unconstrained input in there as well to make things a little bit worse. So the first two slices we've got in there are threat modeling and design review. So threat modeling is a really good tool or practice rather, where you sit with the team, a security trained person, you perhaps use a method like Stride, and you sit with the team and you talk around what potential threats there are to the system. You work with them to distill the things that concern them about the system and talk about the security flaws that they probably know are in that system. And write those down. Look at what potential controls you've got to fix those security flaws, but the whole idea is to catch those design flaws early as possible, where it's cheapest and easiest to fix those before it becomes more expensive to do that. Design reviews, similar sort of aim, but typically uses a InfoSec person to step back, to take a look at that system from a security point of view, and check it, do a design review, and see whether they can spot some of those flaws, and again, suggest controls if they do. So in this case, both of those are aimed more at the design flaws rather than vulnerabilities that are in the code. But the next slice of cheese there is SAST, which is static application security testing. So this is where we've got an application that scans your code, so it's got access to your code, so white box testing. And here's really the earliest opportunity we've got to do that, which is in the actual integrated development environment that the developers are using to code their application. So some of the applications can do it as you type, some of them require you to sort of send it off, but this is before the code's committed. And in this case, that sort of JavaScript eval function is quite an easy one for a lot of those tools to spot. And so that's prevented fairly early that particular code-based vulnerability from getting into the system. So the second red line we've got there, so this is a slightly different scenario. So this is where a developer's been asked to add a rich text box to one of the input fields. So they wanted to put in some HTML tags, they wanted to use bold, things like that. And so in order to do that, they had to set up an allow list for them to allow those tags through, because they're trying to do the right thing on the security side of things. However, they've been a bit lax in that, and they've been a bit too permissive. So there's potential there for things like SQL injection, XSS, that side of things. So again, the first two slices of cheese aren't really going to combat that risk. They're aimed more, as I said, about the design flaws. But the first opportunity, again, like with the last flaw we've got, is the SAST and the IDE. Generally, those tools, as Rafa kind of spoke about yesterday, they vary in kind of quality, but they're quite good at spotting where you haven't implemented any sort of input filtering. However, in this case, it's quite nuanced. There's an allow list, and they often don't check that deep down. So in this case, it hasn't spotted that. The next slice we've got along is secret scanning. So this is aimed more at preventing where the developers accidentally introduced a security key into the code repo. And so there's great open source tools around this, things like Trufflehog, that you can, again, run in automated pipelines to scan over the code and to check for those API keys where they've inadvertently been left in, flag it up to the developer and get them to remove it. The next slice that could possibly catch this is code reviews. But sort of my experience around code reviews is that they take a lot of time to train the team, a lot of input to train the team to effectively do security code reviews. And quite often the developers are very good at looking at functionality and performance angles of code reviews, but not necessarily the security side of things. So in this case, again, it goes through that slice. The next couple of tools we've got here is the SAS tool again. So this is where it's running automated in the pipeline rather than being manually kicked off like the last round of SAS did. And again, it didn't catch it then, so it's unlikely to catch here. It's going to be the same tool that's running. The other thing that runs here is software composition analysis. So this is really good at looking at those dependencies in the code and checking your code to see what versions of the different dependencies you're using and comparing those against databases to check whether there's any existing vulnerabilities in those, and then prompting the developer to potentially update those or patch them. But again, not aimed at this particular risk of where the developers introduced a flaw in the code and configuration. Next one along, container and image scanning. So this is using perhaps an open source tool like Claire to scan your container for any, again, sort of SCA type dependencies in the operating system or the components, and make sure that those are updated and don't have any pre-existing security flaws in them. Again, not aimed at code issues, so not going to catch our particular vulnerability here. The next one, policy as code. So this is where we've got infrastructure as code, and you're checking that against a set of policies. So again, ensuring things like the example I mentioned earlier, you haven't got any S3 buckets set inadvertently to public when you meant to set them to private. So really good at that, but not good, again, for the code tools. The next slice is really good at that. So dynamic application security testing. So this is perhaps using a tool like the great OWASP tool, OWASP app. So it's actually working on the running application, and it's fuzzing all the different inputs to the different web forms. And in this case, because the vulnerability is around having two permissive rules around what inputs get blocked, this is going to smash it with loads of malformed bad inputs and will catch, in this case, that sort of vulnerability. So great, job done. It's taken quite a while to do that, so we'd prefer to have perhaps caught it at the SAS layer of cheese, but still, we've caught it. What else could catch it if, for some reason, it did get through that DAS layer of cheese? We've got pen testing a little bit further on, so that's where we've got, you should be well aware, trained individuals acting like an attacker, attacking that application. And again, typically, they'll run a tool like Burp Suite with a big list of inputs, and they would kind of fuzz it and find similar sort of vulnerabilities. I'm going to talk a little bit briefly around the other slices of cheese on there. So we've got signing. So this is around signing the artifacts, so your exes that are produced by your pipeline or perhaps your containers, and ensuring that what gets deployed is the thing that you're expecting to get deployed. And you haven't got a malicious insider, perhaps swapping in an application that's got malware in it as well, or again, could be a attacker that's got penetration into your network and has managed to swap those over. Got network and container scan here, so same container scanning we ran earlier, but just before we deploy it, just to check nothing got misconfigured in the time when we were building and testing it. And then we've got network scanning here, so this is perhaps using a tool like Nessus on an automated basis to attack your application from more of a network kind of point of view, and find those misconfigurations where perhaps services got left, ports got left open, and ensure you can then react to that and close those ports up. Pen testing I've already mentioned, so the next one, vulnerability management. So this is, again, around ensuring that your application stays up to date. in terms of patching the operating system and any of the major components on there. Your compliance checks is similar to doing policy as code, but on an ongoing basis to ensure that you're following best practice when it comes to configuring your cloud environments. So yeah, the thing I would mention around this is there's some really good OWASP tools, mentioned a couple. OWASP dependency checks are really another good one for the SEA side of things. So a good kind of easy way to get an entry into using these tools because they're free. Obviously, there's a cost to setting them up, but you don't have to use the really expensive commercial tools. First up, you can use these tools, prove out your business case for how effective they're going to be, and then perhaps look to introduce a commercial tool later. So the next slide, what can still go wrong and how can we prevent it? So for me, it's perhaps not considering security early on or on changes. I personally am being affected by this, which is where security tends to be brought in late after a lot of the design decisions have been made, and obviously it's less effective to implement those fixes. And you're not getting the benefits of shifting left and catching those flaws early. Not considering security in your stories, so on changes, you could be introducing new cloud features, functionality. You could be opening up new services and ports. So it's important to kind of review the security of those. One of the means I've seen, a really good way of doing this is having security guardrails. So each time you raise a story, having key questions that the team needs to answer. So exactly things like that, are you using more services? Are you expanding the access permissions potentially by implementing this new feature? And if so, put your hand up, go and speak to a security person, get them to have a look at it and assess the risk on it. Quite a nice way of kind of being able to sort of flag up when the team needs help from a security point of view. The next one is around setting the thresholds for the scanning tools too high. So I've seen examples of this where, perhaps you're just scanning for criticals and highs and not failing the builds when it comes to mediums. But some of you know, some of those mediums can sort of chain together and have the effect of a more critical vulnerability and become exploitable. And similarly, keeping the policies you use in the infrastructure as code policies and the compliance checks, need to keep those up to date as well. So lack of supervision and guidance by security specialists. So this is around spotting, again, those potential design flaws. And threat modeling, development teams might be lacking in skills, like things like Stride, to be able to do that effectively. And as a practice, it's quite easy to forget to do. It can't really be automated. So train the teams up first and foremost, but then also have this as one of the must-haves before going to production. So that will encourage the teams, if they know it's a precondition for going live, and then it benefits them really to get it done early as possible. Training also plays a big part in the code reviews that I mentioned earlier. To get the most out of them, it pays to train the development team up to be able to spot typical security flaws in the code. There's a reliance on humans to fix the vulnerabilities when they're found by the scanning tools, and those fixes are going to be subject to those latent conditions. Security often gets kind of put to the bottom of the pile, and functionality and putting functionality comes in first. So for me, it's around flagging the security stories as security specific or having an impact on security, so you can spot those trends in time and close them and get them fixed. Tooling can often help here as well, so tools like Veracode and others can give you metrics around time to fix. And then again, spot those trends, and if you see that teams are struggling, reach out and help them, get security specialists in to give them some help and how to fix the vulnerabilities in their code or configurations. Another latent condition there, so this is around not having adequate security specialists. We're all aware, there's a skill shortage in cybersecurity. One of the things that can help here is having security champions programs. So this is where you take developers, configurers, architects that perhaps got an interest in security, give them some extra training and have them as the local focus for all things security. So they're on site, they're working with the team daily, they'll be attending their stand-ups, their scrums, and they can help advise the team or ask for help, from security specialists in the organisation. And the last one on there, not doing that software composition analysis on an ongoing basis. So if you're using waterfall methodology or others, you might not actually be deploying often and running those SCA tools to scan for dependencies that have existing vulnerabilities. So make sure you've got a process for doing that. One of the good suggestions here is to still, run your build, which is not, which is having two effects. It's running all those automated scanning tools, which is great, but it's also, from a functionality point of view, proving that your build is still working okay for other reasons as well. So in summary, we looked at the model, we applied it to application security, looking at active failures and some of the latent conditions that can cause holes in the slices of cheese. Just remember, we can't change the human condition, but you can change the conditions that humans work under. And so in order to close up the holes caused by those latent conditions, you can use practices like threat modeling to catch those design flaws early, and you can support the architects and developers with training and help with that sort of lack of guidance and training. For the active failures, have those detective tools in there, support the humans in the system to spot these vulnerabilities and to catch them early. So that's me. Any questions?
How would you go about applying that in a company setting? So how would you go about implementing that model?
Yeah, so
How do you keep it, I guess, updated?
So one of the things I've done recently.
Could you repeat the question first?
Yeah, sure. So how do we go about applying that in an organisation, in a company? So one of the things I've done recently is work with an organisation to create a secure by design framework, which lays out the activities, like things like introducing the SAST and the DAS tools, doing threat modelling, and lucky enough to not just create that framework, but actually lead some of the activities in there. So training the teams up to do threat modelling and helping them introduce those scanning tools into the pipeline. But yeah, that took quite a bit of work to talk to the executive teams, the management teams to get them really on board with that. But yeah, starting with the sort of the framework and understanding where you want to get to in the future, and then also implementing something like the OWASP SAM tool to then measure that maturity over time as well, which again gives some drivers for people to increase the maturity.
Cool. Any more questions?
Yeah, question. It's just around the scanner. I'm just wanting to know what your experience is when you talk about regular scanning. Is everything scanned in one lot, and how regular is this? And yeah, how regularly is this done? What do you recommend?
Yeah, so we recommend it on every build, and it really depends on the speed of the scanning tools. Quite often they'll kind of offer sort of different options around having like a quicker kind of pipeline scan, and as Rafi mentioned yesterday, perhaps have a weekly build that does a more in-depth scan. And again, with the DAS scanning as well, run it as part of your functionality tests and run that as well. Thanks.
Cool, we have time for one more question, I think.
Yeah. How do you deal with time pressure and trying to balance the security concerns against that? You mentioned that time pressure is one of the reasons that these things get skipped. Do you have any solution?
That's a really good question. It's difficult. It really depends.
Sorry, could you repeat it?
Sorry, yeah. How do you deal with the time pressures around, getting the security fixes implemented? Yeah, really good question. It really depends on the appetite of the organisation to a big degree. I mean, you can encourage them as much as possible, but yeah, quite often it's really the appetite of the organisation. And the sad thing to say is quite often, security doesn't get a look in until an incident happens, and the company sort of wakes up to it. And we're all in the cybersecurity community. That's the last thing we want to see is incidents happen. But there can be that sort of positive knock-on effect that then it starts to come under the microscope and get the attention and the investment that it deserves. But yeah, it's knowledge, awareness. It's outreach in terms of talking about the potential losses and damage that could occur with different cyber attacks, and yeah, getting that message across as often as possible.
Cool. Steve's done a great job preparing his talk and spent a lot of money on pictures, not cheese. So let's put our hands together and thank him.
Brilliant. Thanks a lot. Cheers.